Assalamu alaikum students. Today we discuss about the composition of relations. Composition of relations. We have discussed about the relations. Now we see how we make the composition of these relations. Let R and S be fuzzy relations. Fuzzy relations in U cross V and V cross W respectively. And let delta be a T norm, and let delta be a T norm. The composition R circle S of R and S. The composition R circle S of R and S with respect to delta is the fuzzy relation on U cross W. With membership function R circle S of UW, for example UW are two fuzzy numbers, fuzzy sets, is equal to maximum of RUV delta SVW, and V belongs to V. Here we can take x delta y is a T norm is equal to x min of y, or we can also take x delta y is equal to x multiplied by y. We can take any T norm. So in this way we will first calculate the max min composition. And similarly for multiplication we will find max product composition. We will solve an example for max min composition, and this example will be with the fuzzy matrices. We will take an example of two matrices, and we will apply the composition between these two matrices and solve it. Okay. Now we take an example. Find the max min and max product composition of R and S. find the max min and max product composition of R and S. Okay, solution. First we will take R and S. We are given the values of R and S. Here R is equal to matrix 0 0.1, 0 0.0, 0 0.6, 0 0.2, 0 0.3, 1, 0, 0 0.4, 0 0.5, and S is equal to 0 0.2, 0 0.5, 0, 0 0.9, 1, 0 0.3, 1, 0 0.5 and 0 0.4. Here if we see that R has these 9 values. So if we have R, we will be these values are, for example, we can say that here we get the value of x1, x2, x3, and here we have y1, y2, y3, and here again we have some values like s1, s2, s3, and here we have the numbers r1, r2, r3. So if we have the number x1, y1 is your order pair x1, y1, its value is 0 0.1. x1, y2 have the membership value 0 0.0 or 0. x1, y3 have value 0 0.6, and x2, y1 membership value is 0 0.2. Similarly, x2, y2 has 0.3, x2, y3 has 1, x1, y1 has 0. So in this way we have this composition of values. So in place of reading this x1, y1 over 0 0.1, I write just 0 0.1 because we are multiplying the values. We are not multiplying these numbers because these numbers are with them, but we are multiplying their membership values only. So now we calculate R circle S or R composition S. Okay. So we are dealing here with max min product. We are solving it for max min composition. So here is the max min composition. R circle S means we will in multiplication what we do with the matrices, we take the first row and multiply it with the first column of the second matrix. So we will take the first row and take its minimum value with the first column. So in this way we can write that for the max will be applied later. First apply this. We will take the minimum value of min of 0 0.1 and 0 0.2. Then we take min of 0 0.0 and 0 0.9. Then we take min of 0 0.6 and 1. So here we get the first number. Then at the end we will take its maximum value. So we will take min of 0 0.1 and 0 0.2. Then min of 0 and 0 0.9. Then min of 0 0.6 and 1. And after that, when we solve this all, we will take its maximum value. Similarly, first row will be multiplied by the second column. Then we have again this min of 0 0.1 and 0 0.5. then min of 0.0 or 0 with 1. Okay. We are taking here first row of the first matrix and then second column of the second matrix, and then take min of 0.6 and 0.5, and so on. We will go in this way. Here we again, and now we take the second row as same as it is. We will multiply the matrices. We will take its second row. We will take the min of 0.2 and 0.2, then min of 0.3 and 0.9, then take min of 1 and 1, and so on. Then we take second row we will take min its with the second column, then third column, and so on. In this way we will go on. Then we take third row and first column, then second column, then so on. In this way we will solve it, and we will go here. So if we see that, if we take their R circle S, max will be applied later on. Now I will apply it here. For example, if we have R is here, R is equal to 0.1, 0, 0.6, then 0.2, 0.3 and 1, and 0, 0.4 and 0.5. And similarly, if we have S is equal to 0.2, 0.5 and 0, then 0.9, 1, 0.3, 1, 0.5, 0.4, 4. Now we take its min. If we take first row and then first column, we will take min of 0.1, 0.2. We will get minimum of 0.1 and 0.2. We will get 0.1. Then min of 0 and 0.9. We will get 0. Then min of 0.6 and 1. We will get 0.6, because 0.6 is minimum. We will take the minimum value. Now the second, we will take again first row and then second column, 0.5, 1 and this. We will take minimum of 0.1 and 0.5. We will get 0.1. Minimum value is 0.1. Then 0 and 1 minimum value is 0. Then 0.6 and 0.5 minimum value is 0.5. And for third, we will have, if we take 0.1 and 0 with minimum value, we will get 0. Then 0 and 0.3 is 0. Then 0.6 and 0.4 minimum value is 0.4. Now we go to the second row. Now we take second row and take minimum with all the columns. 0.2 and 0.2, we will get 0.2. Then 0.3 and 0.3 and 0.9. Then 1 and 1, we will get 1. Similarly, where we will go to the 0.2 and 0.5, we will get 0.2. Then 0.3. Then 0.5. In this way, now we apply it with the third column. We will get 0, 0.3 and 0.4. Similarly, we will go to the third row. Now we take the third row, 0, 0.4 and 0.5, and multiply and take min of with all the three columns. we will go for the minimum value. So minimum value of 0 and 0.2 is 0, then 0.4 and 0.5. These are the minimum values. Now again we take the minimum values 0 and 0.5, we get 0, 0.4 and 1 we get 0.4. So here we have 0 and 0.4, and the third one is 0.5, because both are 0.5. And then we will go to the next, we will have 0, 0.3 and 0.4 are the minimum values. Okay. So now we apply the max inside the matrix, because here we are taking the max, because when we are multiplying we multiply the numbers and then we will take their sum, but in multiplication we are taking minimum values in place of multiplication, and then after for addition we are taking max of both, max of all. Here we are using all the t norms values. So it is max of 0.1, 0, 0.6, then we will take max of 0.1, 0 and 0.5, then we take max of 0, 0, 0.4, then we take maximum value of 0.2, 0.3 and 1, and then we take max of 0.2, 0.3, 0.5, then we take maximum value of 0, 0.3, 0.4, then we go for the third one, we have max of 0, 0.4, 0.5, then we take max of 0, 0.4, 0.5, then we have the max of 0, 0.3 and 0.4. So what we do now, we will take the maximum value from all the three numbers. We have fuzzy numbers 0.1, 0 and 0.6. So maximum value from these three is 0.6, we get 0.6. Here maximum value is 0.5, we get 0.5. Here maximum value is 0.4, we get 0.4. Now maximum value 0.2, 0.31 is 1, we get 1. Then 0.2, 0.3, 0.5 we get 0.5. Then maximum of this is 0.4. Then maximum of these three is 0.5. Then again 0.5 and 0.4. So this is our composition of two relations R and S. So we get the answer 0.6, 0.5, 4, 1, 5, 4, 0.5, 0.5, 0.4. So this is R circle S. This is the basically the relation of U cross W. So it is so these numbers are of U cross W. That means here we have numbers of U. There may be some X values, Xi, Xj, Xk, and then these are the numbers of U or U values, U1, U2, U3, and here we get W values, W1, W2, W3 values, and these all are basically the membership functions of these numbers, these values. In this way we will find the composition of two matrices or two functions. Now we solve it for S circle R. We find the R circle S. Now we calculate the S circle R in the same pattern. When we are here, these are the same, because when we are taking R circle S, we just take our first our matrix is R and then S, and when we calculate S circle R, we will have S is on first and R is on second position. Okay. Now we find the R circle S max product. Now we go for the R circle S, but the function is now max product. What we will do now? So if for R circle S we will multiply these by For example, R, we will first write R, then write S. R is 0.1, 0, 0.6, 0.2, 0.31, 0.2, 0.3 and 1, 0.45, and S is 0.2, 0.5, 0, then 0.2, sorry, 0.9, 1, 0.3, 1, 0.5, and 0.4. Now we take its max product. First we calculate max min. Now we have a new t norm, because t norm is also a product. We have a product delta which is x multiplied by y. First we take the min, x min y per t norm, because when we are dealing with t norms, our values will be all the fuzzy numbers, because our membership values can never be outside the 0 1 interval. So that's why we are using t norms for product, for any type of calculations. Now R circle S. Max, we will apply here max product of R and S. These are R and S. Where is it? Max product. So max is outside, because max is the first function, and then we apply here the product. Now this is very simple, that we just multiply the first row. We will take here the first row and multiply it first column. I am writing it directly. We multiply by 0.1 and 0.2, we will get 0.02, comma 0 into 0.9, we get 0, 0.6 into 1, we will get 0.6. And now we go to the second one, we will get 0.1 into 0.5, we will get 0.05, then 0, then 0.3, 465 and 30. Similarly, now we multiply first row with third column. We will have 0, then again 0, 0.6 multiplied by 0.4, we will get 0.24. So here we have second. Now we take the second row and multiply all the column. First we multiply by first column, then second column, then third, and so on. 0.2 multiplied by 0.2, we get 0.04, 0.04, then 0.27, then 1, then 0.1, 0.2 will be multiplied by 0.5, we get 10, 0.1, then 0.3 is multiplied by 1, we get 0.03. Sorry, 0.3 over, it will be 0.3, and then 0.5. Similarly, we get 0, 0.0. This is just multiplication, 0.4. And now we take third row and multiply with all the columns. Simple multiplication of matrices. We get 0, 0.36, 0.5, then 0, 0.4, 0.25, then 0, 0.12 and 0.2. Okay, 5 4 the 20, then we get 0.2. Now we apply max inside. So if we apply max, we get R circle S is equal to, we may apply the max inside and we'll get this matrix. maximum value of, we will apply max function on it, and max will be maximum value of 0.2, 0.02, 0, 0.6. Here we can see we're just applying the max or inside. Here this is the max, this is the value, this is the max. We apply on this interval, then we apply with this, we apply max on all the intervals, and then calculate the maximum value of it. Now we go to the max of second order pair. We have 0.05, 0 and 0.3. Then max of 0, 0, 0.24. Then max of 0.04, 0.27 and 1. Then max of 0.1, 0.3, 0.5. Then max of 0, 0.09, 0.4. This is 0.9. Then we go to the third, apply the max on the third order pairs, third row, 0, 0.36, 0.5, max of 0, 0.4, 0.25, then max of 0, 0.12 and 0.2. So this is our matrix. We can see when we are dealing with t norms, our all values are between 0 and 1. These values can never go outside the outside the values of 0, 1. Now we take their max. Now max of 0.02, 0 and 0.6 is maximum value from these three is 0.6. Then maximum value of 0.05, 0 and 0.3 is 0.3. Then their maximum value is 0.24. It is 0.24. And then maximum is here 1, and their maximum is 0.5. Then their maximum is 0.09 and 0.4. Then we have 0.4. Here we have 0.5. Here we have 0.4 and 0.12 is 0.2. So this is our composition of R circle, and this we solve it for max product composition of Rns, composition of R and S, or we can see that this is R circle S composition. Okay, so we solve it for this. Now we see that what is alpha cut composition. For alpha cut composition, we know that, for example, we have an exercise, for an example, that R circle R should be less than equal to R if and only if R is transitive. So here we just apply the max of min of RUV and RVW. We find the min of RUV and RVW, and then we take its max. We will find that it is less than equal to RUW. It always less than equal to, because when we are applying the different t norms or different mean and max functions, then this, after this multiplication, we will get the smaller number than RUW. So in this we have the fuzzy relations. We will take two fuzzy relations and then make its matrix fuzzy relation. Now make some fuzzy relations. with an example. Fuzzy relation example. We make we know that how to make the relations in ordinary math, but now we make the fuzzy relation with an example. Example. Let we have a is equal to x1 x2, and we have b is equal to y1 y2 y3. So we get a cross b. It will be definitely, we know that we will take first numbers as a and second numbers are from b, then we get a cross b. So we have x1 y1 then x1 y2 then x1 y3. These are the fuzzy numbers, and then x2 y1 x2 y2 and last is x2 y3. So in this way, and we can write there, just we have to add their membership values or membership function. So for example, x1 y1 has membership value 0.2, x1 y2 has membership value 0.3, and this has x1 y3 has 1, then x2 y2 has membership value 0, and this has membership value 0.5, and this has membership value 0.7. So we can write it in this way. We can also write it in this way, that x1 y1 bracket then comma, we write it 0.2. We can write it in this way as well. We just add one order pair here with bracket and a comma, and we can also write by dividing it by 0.2 or 0. By divide, we just write this as a patterns. We can write it here, and we can write it also in the denominator as well. So if we are making a relation R, then we can write in this way. For example, if in simple numbers, when we are dealing crisp numbers 0 1 in integers, in simple math, we just write it in this way, that this is x1 x2, and here we have y1 y2 and y3. Okay, and we see that we get a fuzzy relation. X1 y1, we can write 1 0 0 and then 0 1 0. So it means that in this relation R1, or we can say any relation, for example, we are taking R1 relation, here we have only x1 y1 order pair and then x2 y2 order pair. This implies that R1 is equal to x1 y1 and x2 y2 order pair. These two are order pairs, because only x1 y1 has a number 1 and x2 y2 has 1. All other are 0, means these are not included in the relation R1. But in fuzzy relations, when we are dealing with fuzzy relations always are from, for example, this is our fuzzy relation and it is from u to 0 1, u square to 0 1, u to 0 1. So we say that this is fuzzy relation. And how we make this fuzzy relation R? For example, we are making a fuzzy relation R, then it can be written in this way, x1 x2, and here we can write y1 y2 y3. So if we are writing this fuzzy relation 0 a cross b, we can write it in this way, x1 y1 have 0.2 as membership value, x1 y2 has 0.3, and x1 y3 has 1, then it has x2 y1 has 0, and x2 y2 has corresponding value 0.5 and 0.7. So this relation, this fuzzy matrix shows the relation between set A and set B. This is the main, this simple matrix is showing the A cross P whole by A cross P whole order pairs. All the order pairs are in this matrix. So we can, in fuzzy numbers, just we are dealing with the numbers between 0 and 1, 0.2, 0.3, 0.5, 0.4. We are dealing with these type of numbers. Then we say that it is a fuzzy relation. For example, we take one more relation and solve it. For example, we have a relation R from A cross P to 0, 1. We have a relation R, fuzzy relation R. You can write fuzzy relation this way. This is A cross P to 0, 1. Then, what is this? We can write this fuzzy relation R as x1 y1 comma 0.2. We can write it in this way. As we can write it in the denominator. This is an this is also a pattern. We can write it in this way as well. Then x2 y2 as 0.5. So in this relation we have only two numbers, two fuzzy numbers, two fuzzy order pairs. First is x1 y1 with membership value 0.2 and x2 y2 with membership value 0.5, and all other numbers are 0, and all other numbers are not written here because they have the membership value as 0. Now we think about the complete relation of A cross P. What is the complete relation? Complete relation of A cross P in fuzzy matrix. It is complete when fuzzy relation R is, this is x1 y1, this is y1 y2 and then y3. We have, for complete we say that all the relations are, all the fuzzy order pairs have the membership value 1, 1, 1, this is 1, this is 1, this is 1. Then we say that this fuzzy relation is complete. And what is null fuzzy relation? Null fuzzy relation. Null relation is of A cross P's it is null relation if R is equal to 0. If we have here x1 x2, sorry, if we have here x1 x2, then it will be 0, x1 x2 y1 y2 y3 is the upside. We get 0 0 0 and 0 0. If all the membership values are 0, then we say that it is a null relation. Okay, these are the two relations. Now we take an example and we see that if we have two relations R and S, then how we take their union and intersection and how we take their complement. This is just an example. So we see that if we have two sets R and S, we have the set R and S already. Now we calculate their R union S. So for example, if we have R is equal to 0.2, 0.3, 0.7, 0.9, then 0.5, 0.2, 0.3, 0.7, then 0.1, 0.3, 0.9, 0.8. We are taking a good example. We are taking its union with S, and here S is 0, 0.7, 0.1, 0.8. Similarly, 0.9, 0.2, then 0.7, 0.1, and 0, 0.3, 0.9, and 1. Now we take its union. What will be the union of these two? For union we usually apply the max t norm. So we are just taking their max. We are taking the maximum max. We are taking the max of both these relations. So what will be the max? We just take the maximum value, max of 0.2 and 0. We write here max of 0.2 and 0. Then max of 0.3 and 0.7, and so on. We write in this way, and we solve it for the new RNS. So in this way we will get R union S is equal to, if we are taking the maximum value of these two, we will see that max of these two RNS is for example max of 0.2 and 0 is 0.2, sorry, then their max is 0.3 and 0.7 is 0.7, again 0.7, 0.9. you can solve it in this way. We get the answer 0.9, 0.2, 0.2, 0.7, 0.7, 0.7, then 0.1, 0.3, 0.9, and then 1. We just do like this, just we are adding, but in addition we are using a max function or maximum value of these two. Similarly, if we are finding the intersection of our two fuzzy relations, then we just apply the min function of both R and S. If we have R and if we have S, then we can just apply their min. For example, we take the same R and S and we just have to do what we do, that we just take their, we will write R here 0.2, 0.3, 0.7, 0.9. Similarly, where we have 0, 0.7, 0.1, 0.8, and so on. All other are same. Then we take their minimum R intersection S. Then we just take the minimum value of this. We will take min of 0.2 and 0, and we will get 0. Then min of 0.3 and 0.7, it will be 0.3. Okay, and in this way we will take min of 0.7 and 0.1, we will get 0.1. 0.9 and 0.8, min is 0.8, and so on. So on, we will solve it, and we will get here 0.5, 0.2, 0.3, 0.1, then 0, and then 0.3, 0.9, and 0.8. In this way we can find the R intersection S. This is basically the min function. We are applying the min t norm in this. We can also apply any t norm. You can be asked that just apply delta 1 for intersection of R and S, or the same as this we can apply different t norms for this, but the usual t norm for intersection is min, and the usual t norm for union is usually max. Now what we have to find, we just the last example for this is, if we have to find the R complement. What is R complement of R? It will be 1 minus R, or what we will do, we just minus the 1 from all the whole R. So it can be written in this way, that 1 minus R, we write all the set R. What is R? It is 0.2, 0.3, 0.7, 0.9, 0.5, 0.2, 0.3, 0.7, then 0.1, 0.3, 0.9 and 0.8. We just minus it from 1, then we will get 1 minus 0.2, we will get 0.8. 1 minus 0.3, we will get 0.7, then 0.3, 0.1. Okay. And here we have 0.5, 0.8, then 0.7, then 0.3, and the third and last is 0.9, 0.7, 0.1, 0.2. So this is our R complement. In this way we can find the R complement of any matrix by just subtracting minus from the all values. So some more functions to apply the different T norms. Now we will solve it for alpha cut. If we have a matrix S, for example, this is very important example, this is an exercise, you can see, if we have a set S or a matrix S, just solve it for it, and we know that this matrix usually have some x cross y, some u cross v. This S will belong to some u cross v relation, which said u is multiplied by v, then we get this matrix. And for example, we have S is equal to 0, 0.7, 0.1, 0.8, 0.9, 0.2, 0.9, 0.7, 0.1, and 0, and this is 0.3, 0.9, and 1. If we find the alpha cut of it, we just want to find the alpha cut. If we see that what is the alpha cut of this set, and this fuzzy matrix R, this fuzzy matrix S, alpha cut of S, to find the alpha cut of S. So let our alpha cut is 0.4. Then what will be this fuzzy matrix S has alpha cut 0.4, then what will be the alpha cut of this S? This is equal to, what is this? We just take the values, which are greater than or equal to the 0.4, and we neglect all other values. For example, this is less than 0.4, so it is 0. It is greater than 0.4, we will write it 1. For example, we have here x1, x2, x3, and here we have y1, y2, and y3 is y4. Then what will be the matrix? Now this 0.1 is less than 0.4, so it is 0. This is 0.8 is greater than 0.4, so we will write it 1. Then again 0.9 is greater, so 1. Then 0. 0.7 is greater than 0.4, so 1. Here again we have the 0, because 0.1, this is 0.1, 0.1 is less than it. So here we have 0, 0.3 is also less, 0.9 it is greater than, so we will write it 1. This is just 1, so it is again greater than 0.4. So this is the alpha cut of set of matrix S, with alpha cut is 0.4. Alpha cut can be 0.4, 0.5, 0.8. We can take any alpha cut here. So in this way we will deal with the alpha cut in the matrices. Okay, thank you.